Hey guys, thanks very much for sending in your questions about life here at the South Pole. Sorry it's taken so long to get back to you. I actually recorded this a week ago, but I made a mess of the audio and it turned out to be half an hour of silent video. So I'm re-recording this now, and hopefully it will work. So I'm going to go through the questions that you asked in the order that I have them. Some people asked questions which were very similar, and there were kind of questions which related to each other, so I'm going to kind of jump between things as I need to. We're going to start with Anna from Belgrade. The short answer is that we don't really do much research about the early universe at Ice Cube. However, there are several experiments at the South Pole who do. And they are the South Pole Telescope, or SPT, and BICEP. And both these instruments are concerned with the cosmic microwave background, and they are radio instruments. And I can turn the camera around and show you the view out of our conference window. So let me just adjust this here. So you can see a number of buildings. On the left, so where's my finger? This guy. This is Ice Cube. This is South Pole Telescope, and these two, so there's a very small dish you can see here, and here, this is BICEP. So SPT and BICEP are radio instruments which are looking at the CMB. SPT is a 10-meter dish, which is pretty big, and you can't really see it from here. I guess we can zoom in a bit more, maybe. Yeah, so these are the instruments which are looking at the early universe. Ice Cube doesn't really. And you can see that we've got this this flag line. So the walk out to the instruments is maybe 1 kilometer. And we use these flags to make sure we don't get lost. So if the weather's really bad, we follow the flags to either get to our telescopes or to get home. And now let's come back and let's you can look at me again. Yeah, so that's kind of about the early universe. Ice Cube doesn't, SPT and BICEP do. Well, we have clocks. I use my watch, which is currently charging. I guess the question really is what time zone do we use? So the South Pole operates on New Zealand time. And the main reason that we do that is because that's the time that aircraft use when they fly from New Zealand to McMurdo, which is a base on the coast, to here. So yeah, we run on New Zealand time. Ice Cube as an instrument, as an experiment, runs on UTC, so Universal Coordinated Time. This is like a sort of standard time for the whole world. We have very sensitive GPS receivers in our laboratory, which we use to take time from. And actually, Ice Cube would not work if we didn't have GPS. We need very accurate timing all the time. Yeah, so the short answer is that we use New Zealand time. We have clocks everywhere, and for sort of precise timing, we use GPS. Neutrino astronomy is a fairly recent field, but essentially what we want to know is where the neutrinos come from and where are the sources of very high energy extragalactic neutrinos. So if you imagine that we can produce very pretty images of the Milky Way in visible light, in optical light. We can produce radio images, images in X-rays, in gamma. What we're trying to do is produce a picture of the universe in neutrinos. So basically that will show us where do these high energy neutrinos come from. And that is kind of what neutrino astrophysics is. Ice Cube is also, the more we understand about neutrinos, the more we understand about particle physics and the standard model and kind of the fundamental way that our universe works. So how do we detect neutrinos? I think no one asked this, but this is probably quite an important thing to understand. Neutrinos are elementary particles. They are very light, they are almost massless, and actually for many years we thought they didn't have mass. And neutrinos only interact via the weak force and gravity. And what that means practically is that they go through almost everything. And it's very rare for a neutrino to interact with something on Earth. And that makes them very difficult to detect because, you can build a big detector and the vast majority of neutrinos will just travel straight through. And in fact, there are billions and trillions of neutrinos passing through your body right now. Most of them come from the sun. So neutrinos are produced, or rather they allow us to have radioactive decay. And so when atoms decay, you tend to get neutrinos. And obviously the sun is a big nuclear reactor, so we get lots of neutrinos from the sun. So neutrinos travel, from space or from Earth, and very rarely they interact with an atom. And when they do that, they can produce a charged particle. And if you remember from the Standard Model, there are 3 types of lepton that can be produced. We can have electrons, muons, or taus. And the charged particle that gets produced depends on what neutrino came in. So if you imagine like a neutrino is coming from, say, the sun, it hits an atom, in our case, in the ice, and it produces a charged particle that depends on the type of neutrino. So if it's an electron neutrino, it's an electron. If it's a muon neutrino, it's a muon. If it's a tau neutrino, we get a tau. And what we're really detecting is these charged particles. So these particles are traveling so quickly that they break the speed of light in the material that they're produced in. That's kind of a weird concept, but it's very similar to an aircraft breaking the sound barrier. So the speed of light is 3 times 10 to the 8 meters per second, but in water or in air or in ice or anything that's not vacuum, the speed of light is lower, and you can break the speed limit if you have a particle that's energetic enough. And when you have these charged particles that are traveling very quickly, they produce what we call Cherenkov radiation. So they, very similar to a sonic boom behind an aircraft, you get a kind of shock wave of light. And it's that light that that's how we detect neutrinos. So most observatories try and detect this Cherenkov radiation. This radiation is blue, they're kind of bluish photons. And probably if you've ever seen a picture of a nuclear power plant underwater, it has this kind of characteristic blue glow. And that is Cherenkov radiation, and that's what we detect. So you can detect neutrinos in air, in water, in ice. It turns out that ice is one of the best materials for detecting neutrinos because when these Cherenkov photons are created, they can travel a very long distance before they get absorbed by the ice. So what this means is that the longer these photons can travel, the more likely it is that we will detect them with our instrument. So the longer this path length is, basically the easier it is to detect neutrinos. So the ice here in Antarctica is very, very clear. We're talking ice that is 2 kilometers down from the surface, so very, very deep. But it is exceptionally clear ice. And this is a much better material than water or air. Now, why do we build Ice Cube at the South Pole? The main reason is that we have a station here. So we have a building, we have supplies, we have an airfield, we can fly in materials. I would imagine there is also ice elsewhere in Antarctica that is just as good as the South Pole. But the reason that we're at the South Pole is because South Pole Station exists. It's a convenient place to build a detector. The question of sort of when do we find neutrinos? So as I've said, there are billions of neutrinos passing through us all the time. What Ice Cube is interested in is the very high energy neutrinos that come from outside our galaxy. And we detect these around once or twice a month, which gives you an idea of how rare these events are. And this wouldn't be possible without an instrument like Ice Cube. So I have a confession, I'm not an astrophysicist. So my job here is as an instrumentation scientist. So my expertise is in looking after scientific equipment. I do have some experience in astronomy and in optical instrumentation, so building things which detect light. I mean, I've always been interested in space. So ever since I was a kid, I love looking up at the night sky. I've always wanted to be an astronaut, and the European Space Agency is currently hiring astronauts, so I'm definitely going to apply this year. But yeah, I've always been interested in space. I did a physics degree. I wanted to specialize in astronomical instrumentation, so building telescopes. In the end, that's not really what I did, but I have worked a lot with astronomers. And I guess the area of astronomy that I'm most interested in is spectroscopy. And spectroscopy is the study of looking at what color light is in a very simple way. So the color of a star can tell you lots of things about what it's made of, how hot it is. You can kind of guess what size it is, what the pressure is on the sort of pressure of the star. Spectroscopy is really cool because there are very few things that, as astronomers, there are very few kind of sources of information you get. You get how bright the star is, what color it is, and how that varies over time. And so spectroscopy is looking at this color sort of factor. And I spent a lot of time building spectrometers, working with astronomers to kind of better calibrate their instruments. Yeah, so although I'm not an astronomer, I have worked with astronomers, and really I'm an instrumentation scientist. Well, as you saw from the video just before, currently it is very grey outside. You can see, this is an American base, that's why there's an American flag. It's pretty much overcast. That is, maybe half the time it's clear. Earlier today, we had a very clear sky, but the weather changes very, very quickly, and sometimes it looks like this. So probably, 50% of the time we have clear skies. It's probably the easiest answer to that. So, auroras are a natural phenomenon. Auroras are formed when energetic particles are dragged towards Earth down magnetic field lines. So if you imagine the Earth is basically a big magnet, and we have field lines coming in at the poles. And these particles interact with atoms and molecules in the atmosphere, and they ionize them. So they raise these atoms and molecules to higher energy levels. And when these atoms relax, they release light. So basically auroras are produced when stuff hits the atmosphere and produces light. And the color of the light that gets produced is dependent on what atom got hit. So auroras can be green, red, purple, all kinds of different colors, depending on what molecules get excited in the atmosphere. And the reason they're at the poles, so we have the aurora borealis, or the northern aurora, and the aurora australis, or the kind of southern aurora, is because that's where the magnetic field lines of the Earth are strongest. That's kind of where they go in. If you imagine like a bar magnet, you have these field lines that are kind of going like this. The density of the field lines is strongest at the poles. Now, in reality, the best auroras are not seen directly at the poles. They're in kind of a ring around the poles. So if you want to see the auroras, you can go to places in northern Norway or Alaska or Canada, and you can get a pretty amazing show. And while we get good auroras here, we will, actually the better places to see them are further north in Antarctica.
Did you ever in your life see the aurora australis?
So I've not seen the aurora australis. As you can see from outside, it's currently almost midnight here at South Pole, and it's still very light outside. We have 24 hours of sunlight a day until sunset, and sunset is in about a month's time. So currently we've not experienced night at all. it's permanently light. I have seen the aurora borealis. I was in northern Norway maybe 10 years ago, and I saw a very, very faint sort of green blob in the sky. And that's something I'm really looking forward to here is to see the aurora at night, because when it gets to sort of winter here and sunset, we have darkness for 24 hours a day. Yeah, so I've not seen the aurora australis. I'm very much looking forward to seeing it. Does this phenomenon occur on other planets? Yes. Essentially, anywhere you have these magnetic fields and you have particles coming in, you will see auroras. So I think certainly Jupiter and Saturn, we've observed auroras happening there. Definitely Jupiter. This is not my area of expertise, but for sure you can get this on other planets.
Did you ever see a penguin in your life?
Penguins are found on the coast of Antarctica. At South Pole, it is very, very cold, and then we have no life at all here. There's no wildlife, no plants, no animals. So penguins are only found on the coast. And unfortunately, I arrived at South Pole before the season when penguins are visible. So I've not seen a penguin here. I have seen a penguin in South Africa. So Ice Cube is buried under the ice. The detector is about 1 kilometer deep. Well, it's almost 2 kilometers deep, actually. Cold affects everything we do. It makes life very difficult because lots of materials will become brittle and break in the cold. Our Ice Cube as a detector is very dependent on power. So we have to make sure that all our light sensors in the ice are kept warm. Otherwise, if they freeze or if they freeze further, we don't know if they will turn back on again when we warm them up. So we try and keep the detector continually powered so that everything is kind of at a stable temperature. Now, that said, cold is kind of useful because it means that we have less noise. So our experiments are less noisy because it's so cold. We don't have thermal noise. But yeah, generally the cold makes everything difficult. Vehicles stop working at some point. Actually, walking out to the telescope to fix things is difficult because you have to wear lots of clothes, and it's quite dangerous because you might get frostbite. But we survive. I think, the cold is probably an advantage in a lot of ways. Let's answer it that way. It's difficult working here, but cold is useful in other ways for us. As I said, it's very cold. Currently it's around minus 50 degrees Celsius. But in many ways it's like working at home. We have a nice building, it's warm, we get all our meals cooked for us, we have nice accommodation. There's a lot to do here. We watch movies a lot. We have there's a big gym. We have a weight room. We have a sauna. We can play pool. We play board games together. So it's a very unique place to be. But South Pole Station itself is a very comfortable place to be, despite how horrible it is outside. It's quite difficult to sort of prepare to live here because it's such a different environment to anywhere else that you could possibly be. But you get used to it. We have around 40 people on station currently. That's our kind of winter population. So you have friends here. You're kind of forced to get along because there are so few people. But everyone's very friendly and nice, and we have a great time. This is a difficult question which I can't really answer. Now, the way that this would probably affect us is that the temperature would get warmer, right? So we'd expect that our maximum summer temperature would be higher than usual. I'm not sure whether that's actually been the case this year. Certainly, if you look at kind of coastal Antarctica, I think we've had, the ice has melted quicker than usual. The kind of stuff that we worry about with global warming. Now, South Pole, we have an experiment or a facility called ARROW, which is the Atmospheric Research Observatory. And ARROW is one of the, I think, 3 sites on Earth which measures the amount of carbon dioxide in the atmosphere, amongst many other things. We have some of the cleanest air in the world here because we're so isolated. So South Pole is a very good place to monitor the atmosphere for pollutants, particularly carbon dioxide. And yeah, while we might not see the effects very obviously here, we are one of the main places that is monitoring global warming and climate change. And the answer to that is really the sun. The sun is the only sort of major thing that affects climate here. If the sun is particularly active, we might have a warmer summer than usual. If the sun is not very active, it might get colder. But that's really the only kind of space phenomenon that affects climate. Now, the sun also affects us in other ways. So we have things like geomagnetic storms. If the sun is particularly active, it can produce these big pulses of electromagnetic energy that can affect satellites and other things. But yeah, in terms of climate, it's the sun. Well, currently it's not dark, so I can't really answer that. However, as a student, I often work at night, and I'm very happy working at night, so I'm not too worried about working during the dark. I guess the main difficulty for us is finding our way outside, and as I showed you before, we have these flags. So when it's very dark, we have head torches, and we follow the flags to get around. So ICL, the Ice Cube laboratory, is made of very common materials. It's made of steel, wood, and lots of insulation. So the station that you can see around me is basically a steel structure, and it's with wood sort of walls. And those walls are filled with very good insulation. It's very thick. We have triple glazed windows. We have lots of heating. So the materials, one of the main sort of constraints we have is weight, because all these materials have to be flown in from somewhere else. So the reason that we use wood is that it's a good insulator and it's light. So most of the buildings here are made of a mixture of steel, wood, and either foam or other kind of insulation. Otherwise, it's a normal building. The answer to this is no. There is a huge amount of stuff going on. We've been very busy over the summer with work, but also almost every night of the week there is some kind of social activity happening. So that might be volleyball on Mondays, we have a TV Tuesdays, Wednesdays we might play Dungeons and Dragons, Thursdays board game night, we have more volleyball on Friday. We've just started watching all the Marvel movies on Saturdays. Sundays we have a sci-fi day, so we watch a sci-fi show. And of course, people might be playing pool, we have a sauna, we have lots of board games, we have, I think, several thousand DVDs. Pretty much any TV show you can think of, we have the box set. So there's always something going on. I also help in the greenhouse here, so we have a greenhouse to grow food. It's very difficult to be bored at the South Pole. And of course, we have to work as well. As I said, we currently have 24/7 sunshine. So really the question is, what is it like to work without night? I think at the moment, I'm really looking forward to nighttime because I haven't seen the stars in around 4 months and I really miss them. Okay, so almost everything we eat is flown in. So we have planes which bring in cargo, and that cargo can be food. We have very big warehouses where all our food is stored. And so the majority of the stuff we eat comes from frozen. And actually we eat normal things. Today we had baked potatoes, we have pizza nights, we have steak. Now this is an American base, so the food tends to be a little bit sort of more towards American culture and tastes. But generally the food is great. It's probably better than the food I eat at home normally. We have 3 chefs, including a pastry chef, so we get really good bread and really good desserts. The food is amazing. That is actually one of the most surprising things about being here, is how good the food is. We also have a greenhouse, so over the winter when we don't get flights bringing in more food, we don't get any fresh food. And the only way we can get fresh vegetables and salads is if we grow it. So there is actually a greenhouse downstairs where we grow lots of lettuce and kale and tomatoes. We have some zucchinis, lots of herbs, that kind of thing. So during the winter, that's how we get fresh food, is we grow it. This is another quite difficult question. It's very hard to prepare for coming here because you have no idea what to expect unless you've been here before. Now, South Pole Station actually has almost everything you need to have an enjoyable time. There's really good food, we have lots of things to do. We get all of our very warm clothes provided for us. So we have to bring things like thermal underwear, so long thermal underwear and tops. But we get warm coats, big woolly trousers, boots, gloves, everything else provided. So what most people do is they bring things which they couldn't get here normally. And that means things that would bring them some kind of comfort. So it might be food from your home country, it might be a book that you really want to read, it might be a game that you like playing. People bring things which are personal to them. So in terms of what I did, I read lots of books, I watched YouTube videos, I tried to find blogs from people who'd been here before, and that helped. But really, the only way you can prepare to be here is to come here, and then you know better for next time. So before coming here, I worked in conservation science. That was my background. But as I said, mostly I work on instrumentation. I build scientific equipment, and I run and maintain that kind of equipment. No, so as I mentioned, South Pole is way too cold for any kind of life. Humans are the only animals out here. So most of the work that we do is we try and fix the detector when it breaks, or when something crashes in the software, we try and fix it. A lot of that we can do from here in the station. Other times we have to go out to the lab to do that. So I normally get up mid-morning. Currently we do some exercise, we go to the gym together with my partner here, check my emails, have lunch, and then in the afternoon, usually we do whatever we need doing. So it might be, we have weekly reports we have to write, it might mean going out to the lab to fix something. We have a mixture of what we call scheduled tasks and, well, not scheduled tasks. So it really depends. We have dinner around 5 p.m. And the evenings are pretty much free to do what we want. So it might be socializing, might be getting some personal time. Yeah, so it's a pretty normal work day, and actually it's fairly flexible, and we have quite a lot of free time with Ice Cube. How cold is it? This is a good question. Right now it is around -50 degrees Celsius. That is pretty cold, and cold enough that you really want to be covering everything on your body, because there's a risk of frostbite if you have exposure to the wind. I mean, the biggest sort of cold problem here is wind. So that is what gets you. If it's a really windy day, you really feel how cold it is. It can get down to -70 degrees Celsius, sometime around September. But the average temperature here is around -50. I will be here for around a year. So I arrived in November. We're probably going to leave around November as well.
Kako hodeš na opačke na Južnom polu?
Well, you just walk. We have good boots. They keep you stuck to the ground, and we let gravity do the rest.
Kako izgleda leto I zima na Južnom polu?
This is a great question. So currently we're in winter because the last flight left yesterday, and that kind of defines the winter season. But really the difference is light. So in the summer, the sun is up. In the winter, the sun is down. At the South Pole, we have one day that lasts an entire year. Yeah, so in the winter, temperatures get very cold. In the summer, temperatures are still cold, but kind of a lot warmer. So it can get to sort of -5, -10 degrees Celsius. You know, similar to Belgrade in the winter. In the winter, it can get down to -70 degrees Celsius, which is very, very cold. And it's dark all day. Those are really the main differences.
Da li na Uranu I Neptunu ima uragana ili tornada? Ćao, idem na Uran I Neptun!
Tornadoes, I don't know, but certainly both Uranus and Neptune have very strong winds. So there are almost certainly hurricanes on both planets. Probably not somewhere that you'd want to be. And, you know, if you're going to go to Uranus and Neptune, make sure you take very heavy shoes so you don't blow away. So, thank you very much, and Hvala. I hope you have a wonderful rest of camp, although it's probably the last day when you see this. I hope you have a wonderful time in Serbia. I was in Belgrade a few years ago and I had a great time. Food is fantastic. Best wishes for 2021, and I will hopefully see you guys soon. Bye. Hi guys, just very quickly, so this is me going outside. We have these kind of airlocks which keep the rest of the station warm. So we have an interior door and an exterior door. So I'm going to go on the observation deck, which is just behind the window that I was answering questions from in the conference room. It's currently around -52 degrees Celsius. I'm wearing a t-shirt, so I'm not going to stay out for very long, but I can just kind of show you what it's like out here. Yeah, so it's pretty cold. You can see my breath is already kind of, it's frosting. In the background you can see South Pole telescope and bicep, and this way is Ice Cube. The actual South Pole is, you can't really see it from here, so this is what we call the ceremonial pole. This is kind of where you go to take pictures. You can see all the flags. The geographic South Pole is kind of around the corner, around there. And yeah, it's snow for as far as you can see. The sun is getting pretty low, so the sun is currently here, and we have sunset in around a month. What else can I show you? This is kind of the back of the station. This is where we store lots of stuff, so we keep lots of things outside. It's very dry here. We can store things in the cold. You can see it's also quite cold in my lungs. This is where we fuel aircraft, so our kind of airstrip is kind of here. Yeah, so -50 is pretty cold, but you can actually go outside for a few minutes and it's not too bad. I'm going to go inside before I freeze. Yeah, thanks.